Okay, so data input, output, data IO, getting stuff in and out of R. This is really kind of a prerequisite for actually starting to do the fun stuff of data manipulation and summarization and all that good stuff, right? We want to get our data into R so we can actually work with it and then save those results so we can, use them later. Okay, so data IO is tricky because it involves both your R and RStudio, but also your computer in general. So bear with us. We'll get through it. I know it's a little tricky. So we'll start with a little setup just to try to minimize those struggles with your computer. Then we'll get into reading a CSV file, which is really common data format, common new user mistakes in reading your data, checking for problems and things like that, overviewing kind of the data input, working directories. We'll talk about writing files and then thinking about R objects and how we can save those for later use. Okay, so we're going to do a little setup first. So we're going to create a new R project. And so this is very important. So hopefully folks are ready to go and can follow along because this is going to help us in the next steps. Okay, so we're going to click the new R project button at the top of RStudio. So if I go to R, this is the new project button. Okay. So a couple more steps. I'll just kind of walk through them in R itself, or RStudio itself. Don't worry about saving your data. If you need to save your files that you're working on, please do that. I'm not going to save my data stored in memory. I'm actually going to create a new project. Okay. So you should see the new project wizard. I'm going to create a new directory, right? You have a couple of options here, but this is going to create a new folder for you to keep stuff. So I'll click new directory. And all these instructions are in the slides, by the way, if anybody gets stuck. I'm going to click new project. And I want to give it a folder name, okay? And so just something that's relevant. So I'm going to call this intro to R class or course or however you want to call it. And I'm going to put this on my desktop. You can put it wherever you like, just as long as it's easy to find. Okay, and I'll create project. Okay, you'll see a couple things have changed. So now I have a nice clean session of R. It's restarted. And you'll see this new project up here on the top right. Okay, so whenever you want to work on intro to R class stuff, all you have to do is go, oh, okay, here are my projects. You select it from the list and you can go to kind of what you've been working on. Okay. And the really nice thing about projects, we'll talk more about this in a second, but it helps you set your working directory, right? It tells R where you want to look for files. Okay. So we'll continue to talk more about that as this lecture goes on. Okay, so again, click the new R project button at the top left. Select a new directory, select a new project. Make sure you input a name that is useful. All right, and you should see now you have a new R project folder on your desktop. If I were to move my things around, you see this folder up here. Yeah? Okay. Okay, so as we move forward in the class, pretty much everything we'll be working with is real publicly available data. So we're not using generated or simulated data. Real data is messy. We all have encountered a kind of a horrible spreadsheet or something like that. So lots of this, lots of the challenges we're going to run into are real challenges. And so we'll use just some open data sources for a few days. And we'll have some added functionality. This JHUR package has some data associated with it, so it can kind of ease the important output of data in future lectures. So we'll talk about that a little bit more later. Okay, as I said, reading in data is the first step of any real project analysis, putting that data in R so you can actually work with it. It's in memory, you can manipulate it, do all the good stuff with it. R can read almost any file format. So if you've got Stata files, you've got SAS files, all that good stuff, especially with add-on packages, you can read and interpret a lot of that material. Just because there are so many folks using R and so many folks working with different data types. And we'll focus on simple comma delimited files first. This is kind of the best practice, very straightforward and simple file type. So comma delimited files that end in CSV, for example. Tab delimited files, sometimes those are TXT files. And just briefly about how you can look at Microsoft Excel spreadsheets and things like that. All right, so the first data set we'll work with is this youth tobacco survey data set. So it's providing states with comprehensive data on middle school and high school students using tobacco exposure, whether they stopped, just tons of stuff about different states, students of different ages, what they know, familiarity, all that good stuff. You can take a look at the data on data.gov if you're curious. Okay, so the data set that we'll work with just for a second here is located on our website at this link. You should be able to click this and be prompted for a download. You may need to do a little bit of wonky stuff in Safari, but if I click this, it's going to download it directly for me. So if I go to my downloads folder, so I see something like this. I see this file has been downloaded, yeah? Okay. So hopefully you're able to download that file. But the next step I want to do is, okay, I want to actually read this into R. So I'm going to need to do a couple of things. I'm going to need to load a library and possibly install a library that will allow me to do this in, a really effective way. So let's go to our R. We're in our project. Things are going nicely. So I may need to install packages, and I will need to install reader. Okay, so that package is downloaded. I only need to do this once because when it downloads these packages, it's this stage of install is just putting it on your computer, and then the next step, library, is loading it, right? We do need to load it every time. Okay, so the library is loaded, ready to go. And I'm going to go ahead and open an R Markdown just so I can type my code out and feel good about it. Put a chunk down here. Okay, so I can type my code here and have it run in the console. Okay, So I've loaded the reader library, and I want to get this data into R. So I can do that with a function called read_CSV, and I'll just need to provide it with some kind of source for that data. Okay, so in this case, I'm providing it with a URL, and so file is equal to some URL that has a data file associated with it, and I'm assigning that to data or dat. Okay, so this has been read in. The head function can help us get a sense of what that data looks like, displaying the first few rows of data that we're reading in. It's a data frame object type. Okay, so really quickly, let's kind of see how that looks in R. I'm going to copy this link. Okay, so I've loaded my reader library. I'm going to say, okay, well, this new object called dat, I'm going to use the read_CSV, and you can kind of see I have some previews. It tells me it's from the reader package. Okay, gives me a little preview of what arguments I need to provide, but in this case, I just want the URL. The file is this. Okay, and let me go ahead and run it. Okay, I get some output. It's telling me, oh, okay, you know, some things are happening. Yeah. And then if I want to look at the top few lines, n equals 5 lines, and run that, I can kind of see, oh, okay, I've got like a year column, I've got a location abbreviation, location description, all this good stuff. Okay. All right. All right, so what's actually happening here? So read CSV from the reader package is parsing this file that we're giving it via that URL, that link, and turns it into a tibble. Okay, so a tibble is we're throwing lots of data types at you, and this will become more clear throughout the course, but turns it into a tibble, which is a special kind of data frame. Remember, these are basically a spreadsheet. It's the core of how data is stored in R. So it's turning it into a table or a tibble you can use where data are split into rows and columns. Okay, so it's a format that's easy on our eyes, right? We can interpret it, we can look at it, and so this is just sort of some details of how that works. Not super key to know, but one thing to point out is that each column type is determined. R tries to guess what this is. If you go back here and see the preview of your data, you can see, oh, year is a double type, which is a special type of numeric we'll talk about later. Location abbreviations, a character type, that makes sense. These are letters, right? Strings. Okay, so it guesses what these columns types should be. Okay, so it doesn't always get them right, but it does a pretty good job. Okay, read CSV, it needs the path to your file. Okay, it will return your data. And so if we were to view the help page, which we'll talk about just a moment, for read_CSV, we'll see that we need to provide a file argument. And then the rest of these arguments are kind of options that we can add, but we'll not need to mess with those right away. File is the path to your file. And just like what we were working with in basic R, these need to be in quotation marks, right? Because it's not an object name and it's not numeric, okay? So the URL, like I did here, has to be in quotations. Okay, The path can be, or that file argument and the path you provide can be on your local computer. You can provide an absolute file path, and so this is just, the organization of your folders on your computer. You can provide that. With an R project, we can provide a relative path, which again, talk about in just a second. And we can also provide a URL, okay? And so these are some examples of this. So, maybe we're assigning a object called dat or reading a CSV from a set of files on my computer. So maybe I'm looking in users, Ava Hoffman, the downloads folder, and my data is here, right? That jives with what I've got right here. I've got it in my downloads folder. Okay. Assuming R knows where to look, I can just use the relative path, the file name here. And so R projects will help with that, and I'll show you just a moment. And we can also use URLs, right? So if we're using a CSV file that's online somewhere, we can just provide that. Okay, so this is all like fine and very exciting, but what's our path? How do we figure out what that is when we're working with files on our local computer? And this is not a super easy concept, but we'll break it down and make sure it makes sense. All right, so we set up an R project. So one thing we can do is take the file that we downloaded and add it to this R project directory that we created. Okay, so if I say, okay, I've got my file here, I'm going to move this to that directory that I created. So let me move some stuff out of the way. I know there's a lot of windows going on here, but I'm just going to take this and I'm going to put it in this folder. Okay. So now I should see, I see a couple of the projects or the files that were created when I made this folder, but I also see this data is here now. Okay. And so of course this will work a little bit different on a Windows machine, but we can always help diagnose if there's any issues with that. All right. Okay. So now I'm in that R Intro to R class project. I can use the relative path because the project has already been set up, and I can say, oh, okay, read CSV is just the file name. It automatically knows to look in that folder. Okay, so if I do another chunk down here, if I do dat is read underscore CSV, file is equal to youth, and I might be able to even autocomplete here. Yes, so tab to autocomplete, it knows it's already ready to go. It knows where to look for this file, and I can go ahead and run it, and it's reading it from that file that I downloaded. Okay. And again, this is the relative path. I'm not providing anything like, users, or like on a Windows machine, like the C drive, right? Like something like that. Okay. And this can be useful if you're, working with collaborators. Your absolute path is not going to be helpful for them. All right. Any big pressing questions? I see where the chat is blowing up, but hopefully Carrie and Alex are on it.
There was a request to walk through one more time. Maybe you can briefly do that.
Yeah, absolutely. The creation of the project.
I think so. Is that correct? Is that what you want walked through again? The project creation? Yes.
Okay, sure. Yeah, I know it's super super tricky and lots of button clicking. So I'm in R. Right now I'm in Intro to R class, but let's say I wanted to create another project. I click this button here. Oops, why? Oh goodness, things are a little frozen. Oh, there we go. Okay. This scared me for a second. So click this button here. So this is going to create a new R project. I'm going to not save my data. I'm going to create a new directory. I'm going to create a new project. So it says create a new project in an empty directory. Perfect. That's what we want. None of this fancy stuff. Okay. And so maybe this is Ava's folder of wild ideas. Okay. And just give it a name for this class or however. And it's going to create this on the desktop. You can also change where that happens. I'll create project. You see a little dialog that it's switching projects. It restarts the session. And you can now see that I'm in a different project. Okay. But I'm going to actually switch back to this one. Okay. And amazingly, all of our work is saved. Very exciting. Best practice to save your file though. Okay.
But there's also a great question about spaces and path name or file names, directory names.
Spaces in directory names. So you can have spaces here. I like to use underscores just because I think that's best practice. But if you wanted to create a project that had spaces in the name, that's also fine. And the nice thing is, if you have a file that has spaces in the name, you can have those. Like if the file was named like that, that's totally fine because it's in quotations. Okay. Hopefully that answers the question. Okay. Let's move right along here. Okay, so we may encounter other types of data. So read CSV is actually just a special case of read delimited or read delim. It's a really general function to read any kind of delimited data into your into R as a data frame, as kind of this table spreadsheet situation. So read delim needs your path to your file, just like read CSV, and it also needs the delimiter. Okay, so you need to tell it, is this a tab? Is this a comma? Is it space? What's going on? How is the data separated? What do you want me to do? Read delim is kind of like, it's a slightly dumber function, right? You need to provide a little bit more information versus read CSV. It assumes that things are comma separated. So let's see kind of what this looks like. We're going to need an argument that is for file that tells R where to look. And we need an argument that tells us, okay, what's separating the fields within, an individual line of data. So just like with read CSV, I'm taking this dat and assigning something to dat. I'm going to use the read underscore delim function. And then I'm kind of going to provide it with an argument. So file is this youth tobacco survey, CSV, we just messed around with a little bit. Then I'm going to provide a comma for the next argument. And that argument is delim is equal to, and then I tell it what the delimiter is. Okay. So in this case, I'm telling it, oh, okay, well, this is a CSV file. It should be separated by commas. Okay. And so let's say we have a different kind of file that's actually a tab delimited. Yeah, it's ending in .txt. I can tell it, oh, okay, delim is this \t, which is what we indicate in plain text for a tab. Okay, you may have enter delimited data, which would be /n. You may run into lots of different kinds of delimiters here. Okay. All right. So you may find that you want to organize things in your R project a little bit. You can also tell it, I've got a folder in that project called data, and you're storing that file in the data folder. So if I go over to my folder, so let's say, okay, maybe I want to create a new folder called data and put this in there. Okay, keeping things organized, right? If I go back over to R and I can see my files here, oh, okay, I've got my data folder, I can look in it, and I've got my data in there. Then I can use a slightly different command. So let's look in data to read this file. Oh, I need my reader function. Whoops. Okay, so anytime you switch between projects, you'll have to kind of load that, running that, and it's read it in from the data folder here. Okay, and as I said before, data is successfully read into your R workspace. It's now saved as this object called dat, and it gives us a little column specification, tells us that there's some columns that are character type, there's some columns that are double precision numeric type, which we'll talk about a little bit later, but there's numbers for year, that makes sense. And we can also use some commands to get some information about the data. So we can use the spec command, which we'll talk about shortly, or somebody mentioned the str command. We can use that to get some information about the data. Okay. Okay, so we've got a year column, we've got a location column, and it previews, oops, kind of messy output here, right? So it gives us a preview of kind of what those columns look like. Okay, so years, 2015, etc. Okay. All right, so things that we might run into. Okay, so working directory problems, trying to read files that R can't find, right? So it just means that the path that we provide is possibly wrong and we need to correct it. Typos, again, just like I mentioned before, R is case sensitive. So if you spell things wrong, it's not going to know where to look. If I say, oh, okay, maybe I spelled this wrong, it's like, that file doesn't exist, right? You got to make sure your spelling is correct. But luckily, auto completion, if we hit tab, is often a capability that RStudio has built in. And so if we have a file name, we can tab to autocomplete a lot of the time. Okay, and that can help with some of the typos. Data type problems, as we mentioned before, is this a character string type or a number? Open-ended quotes, parentheses, and brackets, just be aware that you need to close those, and different versions of software. We've talked about that before. Okay, so our data was read in. We want to kind of start getting a sense, getting a feeling for the data. We can do that with the spec function. And so spec is just what it sounds like. And it takes one argument, and that is the data object. Okay, so if we do spec here, stat, we get some information about those columns and what type they are. Okay, so I'm interested in age, and for some reason it's a character type. That seems like a little wonky. Maybe age should be a number, but maybe it's there's a little bit more nuance to that. Okay, maybe it's like middle school or high school or something. Okay, so the problems function, I know we're throwing lots of functions at you, but not expected to memorize these. The problems function shows you if there are any obvious issues when the data was read in. You know, there was some wonky formatting or lots of missing data, missing commas, you know, things like that. The output of problems is a tibble showing each line with a concern. And so if we run problems on our data set on DAT, we get nothing, right? And this is actually good because it means that it's like, okay, well, I didn't see anything obvious wrong with it. No weird file problems or anything like that. Doesn't mean that our data is perfect, right? It doesn't mean that there's not changes that need to be made or cleaning that needs to happen, but it means that the reading in process seemed to go okay. Okay, so DAT looks good so far. So what would we see if our data was messy? So this is just a hypothetical. We've got this really fun UFO data for another class that we teach. It's just horribly messed up. If you read that in and run problems on that object, you get an output that says, oh, okay, row 16, column, something's happening really weird. It's got like 400 extra columns that it doesn't need. On row 47, column 2, something's going wrong. So it's a little bit helps you diagnose some of those problems. And so we've got actually 72 rows of incidents that it detected. Okay, so, but like I said, DAT looks good so far. We didn't get any output. We think the data was read in okay. All right, so like I said, we're throwing a lot of functions at you, and it may be helpful to, you know, oh, what does this function do? Get a little bit of a reminder. You can use the question mark and then the function name, or help and then the function name in quotations. You can use either of these to get a little bit more information. And so if I go, oh, okay, well, what does read CSV do? I type the question mark first, and it comes up with a help page. It says, oh, okay, yeah, this is helping me read a delimited file, including a CSV or TSV, into a tibble. Special cases, they're used for reading most common types of data, all that good stuff. And then it shows me the usage. If I scroll all the way to the bottom, it will show me some examples. Okay, so I use the help all the time because I don't remember off the top of my head what every single function does. And sometimes I need a little bit of a reminder. Okay. All right, so you can also do a little bit of a kind of a GUI or manual non-code way of reading in data from the RStudio toolbar. This is like just a little bit different. If I want to do things manually, so let's say I go to File, and let's see, where am I, and why am I not seeing it? Oh, import data set, that's right. So File, import data set from Reader, and then I can browse for the file. Maybe it's in my downloads, but in my case, it's I put it on my desktop in my data folder and say, okay, this is the data set I want to open. And it actually gives me the code, right? So if I forget how to do the code, this is kind of nice. It previews it for us. I'll go ahead and import it, but it also uses this really nice view command that will actually open up a table in RStudio. So let's run that. Boom. So I have a really nice table to look at and can get a sense of what the data looks like. But you do want to be careful with this view command because, or this view function, because if you have super big data, this is going to bog down your R's memory, and it will take a very long time to load, and might not even help you that much. Okay, and so here's just a GIF of that same process if you need to refer to it a little bit later. Okay, so there's also, and I know we're coming up on break, but we're almost done here for before we jump into lab after break. There are also data importing functions provided in base R rather than the reader package. And so these are very, very similar, but they have a dot instead of an underscore. Okay, so they have slightly different syntax for reading things in, but we really prefer you use the reader functions. They just work a little bit better and do a little bit better job of preparing your data. All right, so here are the highlights. The tools from the reader package are read delim and read CSV. These functions are going to be super essential. We'll need to provide a file path, and it will parse and return a special kind of data frame called a tibble. Okay, and that is going to be the meat of where the cool data manipulation and data summarizing and stats is going to come from. A couple functions to help you kind of get situated and look at things are this head function, which shows you the first few rows, the tail function to see the last few rows, view to show the data as a spreadsheet, and spec to give you the specification of what those columns look like. Okay, and from the reader package, there are other, you can work with other file types. If you use the read delim function, you can just tell it, oh, okay, I want it to be tab delimited. And then finally, super briefly, for reading Excel files, you can do a couple different things. There is the read Excel function from the read Excel package. You will need to install and load that one. And there's also other packages that attempt to do kind of the same thing. The Haven package is another useful one for you to read SAS, SPSS, or Stata formats. And so they work much in the same way as read underscore CSV. You provide a file name and can start working with those right away. So let's keep moving. Just got a few things to cover. Okay, so I talked a little bit with my group just super briefly about working directories. When we set up our R project, it sets this up for us, but a working directory is a folder that R assumes you are working in. This is where R is looking for the files. And so setting a working directory means specifying where R is going to go to look for that. And so in your project, you can test this out with the getWD function. So if I am in my project, this intro to R class project, and I type getWD, it's telling me, oh, this is a folder that I made on my desktop, and it's going to look for that first, right? So that should square with what I did when I created the project. Makes sense. Okay. If for some reason I need to set a working directory, I can do that, but I like to do this through projects because, it's a little bit more reproducible if, my collaborator wants to use this code. Okay, so just a little quick notes about this working directory. So again, it uses a working directory as the starting place when searching for files. So if you say read CSV and then a file name, R assumes that file is in the working directory. So it would assume it's in this folder. Okay. If I were to say, okay, read CSV data / bike lanes long CSV, R assumes that data directory is in the working directory. So it assumes this folder is inside the working directory. right? So if you use an absolute path, I type out all of the information. It's just like my complete address of that file on my computer. The working directory information is not used, and it just goes to the absolute path. But then that makes it kind of hard for my colleagues to use it, just because their computer is not going to have this information on it, right? Okay. So as I said before, setting up an R project can avoid these headaches by telling R where the working directory is. It's going to be wherever this R proj file is, right? So if I go over to R, I can see, oh, this intro to R class project is in this intro to R class folder. And I can kind of see that again with my files. If I go in here, I can see this R project file, right? And so that's going to be my working directory for this project. Okay. Okay, and super quick, we'll cover a little bit of data output. It's nice to be able to read in data, but maybe we need to write out some clean data. So the reader package does this, much in the same way we would read data in. And so the counterpart to read CSV is write CSV, or write delim, and others. So we'll need to provide a few arguments, which we'll talk shortly about. Okay, so the first thing is whatever data frame or data you want to write to your file. And the second argument is this file argument, and that's what you want to call it, right? And so this could be whatever name you decide to make up. And the nice thing here is you can choose the format you want. So if you suddenly decide you want to do a tab delimited file, or you want to switch over to comma delimited, you can do that at this stage. Okay, you may also find that you want to save one of these objects that you've created in memory. So we've created X, we've created my num and name and all these things, but maybe you want to save them to use them later because if you quit out of R, it doesn't necessarily save those objects in memory. And so if we want to save them, we can do write and read RDS, right? That's our data file, right? And from the reader package. So how does this work? If we want to write an object to be used in R, we just do write RDS, the object we want to write, and then the file name ending in RDS. Okay, and so by default, this is going to go to our working directory, which we just talked about. So, let's say we want to write a variable, a vector called X, and it's containing these numbers. We can just do write underscore RDS, the object, and then the file name. And then same thing, if we want to read it back in, all we have to provide is the file name. So that would be read RDS, file equals, and then the file name, and from the working directory. Okay. And so in this case, I've assigned it to a object called X2. Okay. And if I print that, it will show me the same thing as I had up here. Okay, so just several steps of writing and then reading back in. So you can do that if you want to save things along the way. All right, so we've covered a lot with data I/O, but our projects are a really good way to keep your files organized and reduce headaches. So very important that we get set up with that, and please let us know if you're having any struggles with that. Use read CSV and read delim from the reader package. You may have to load that with library reader to read in your data. And so don't forget also to use the assignment, that like left-handed arrow, to assign your data to an object. Because if we are just reading it in, right? Or let's say we just run this right here. It's reading it, but it's not giving it to an object, right? So it reads it and then it disappears from memory. We want to save it as an object. Whoopsies. We want to save it as an object so we can actually do stuff with it. Okay. Use the spec function to understand your variables or your objects. Use head and tail to preview the first and last lines of the data. I think that's super handy. You can also use the view function. The V is uppercase. And then finally, you can use the counterparts write CSV, write delim, or write RDS from the reader package to write any kind of data you're modifying or save things along the way. Okay. All right. So let's jump back to our lab sessions and get a little bit more time to kind of practice this stuff before we wrap up for the day. Okay. So I'll go ahead and open those right back up.